Welcome back to Detection Dispatch, your go-to for all things detections, threats, and the occasional spicy take. I'm your host, Alex Hurtado, live from the San Francisco Bay Area at RSA 2025. And today, we've got a bit of a cloud edition one for you. We are jumping pretty headfirst into the wonderful but also very terrifying world of AWS access, key leaks, and S3 bucket breaches. And I'm joined with none other than Kennedy Torkura, returning guest of the podcast. Kennedy, I'm so glad to see you back.
Hey, Alex, thank you so much for bringing me back. I really enjoyed the first session we had, I think, getting to a year ago, and I'm super happy to come here again to share some learnings around cloud attacks.
I love the content that you produce always, Kennedy, because you don't just stick to theories and just talking to stars, and as far as because you're a content creator building AWS community, where you always talk about practical uses and you're simulating the real deal. And that's kind of what we're doing today, right? We're simulating what the potential situation where an access key can be exposed, because so many of them are out there and floating across GitHub and the dark web and probably everywhere in between. So I'm really excited to do that. And why it matters a lot, like what you always got to think about why it matters now is I've been seeing some pretty big logos in companies where they've taken some hits on S3 breaches, like Mercedes-Benz and Cloudflare and Adobe. Big players have been caught with their buckets wide open, essentially.
Yeah, exactly.
Yeah, so I want to dive in, understand the bigger story with you, and how sometimes how small slip snowballs can kind of roll down into a potentially bigger compromises. So we can get into it here. We're going to go through two attacks. You guys know Kennedy, and if you haven't, please follow, like, and subscribe to his content. He's talking about AWS content all of the time. But we're going to go through two types of scenarios together and actually hack some S3 buckets, and provide some detections that you can access on our open source community GitHub, right, around some of these scenarios. But also, we're going to go through the examples live. So the first one is going to be a bit of a SSRF attack chain walkthrough, which can very much lead to an S3 bucket exfiltration, but via an SSRF initial access compromise. So Kennedy, you want to walk us through this a little bit?
That's very, very interesting. So thanks so much for the very nice diagram. So the server-side request forgery attack, which is kind of the nice name, for this attack, it's not very new. But just like you talked about the S3 buckets, these are not new attacks, but they still occur all the time. So this attack became popular, I think, after the Capital One data breach of 2019. And so basically, and this diagram kind of shows the major part. So it normally starts from an attacker getting access to an access key, and AWS access key and secret. Could be from anywhere. Most of the time, these are usually kept in GitHub repositories just to automate deployment and other stuff. So that's one major source where these keys are collected. Oftentimes could also be that they are gotten from, so a malware is installed in a like a developer's PC or something like that. But that's where it starts. And once the attacker gets this key, the next thing is he might try to do some reconnaissance. So he tries to more like understand the capabilities of the key to see if it's still even a valid key at all. So he will try to use it. He will try to connect with, against the account. But oftentimes also it could lead to other things like, getting into the account, trying to steal things, trying to go to S3 to exfiltrate objects and things like that. But the other thing I need to mention, especially what happened during the Capital One attack, it started from a reverse proxy. So basically, something like a reverse proxy is kept in front of a virtual machine, and then somehow the attackers, were able to get into the virtual machine by basically bypassing this reverse proxy. And they were inside, once they're inside the virtual machine, bear in mind, at that point in time, the attackers don't have access to the key yet. So they're basically in a virtual machine. And now what next? How can they get into the cloud account? And these virtual machines have the instance metadata service, which is a service that is popular among all cloud service providers. It allows applications that are in a virtual machine to be able to get information about the virtual machine, about security groups, about all that stuff. And they can actually query this instant metadata service and get secrets. Basically, it's a type of credential. So this was what actually happened in the Capital One attack and in most of the SSRF attacks. So once they get that credential, they basically can make calls as normal and they can get into the cloud account. They can, for example, go forward and do things like exfiltrating data from databases or from S3.
The downstream impact. So what a
Yeah,
classic server-side request forgery. So and what I made from that is when an attacker finds a bug, right, in the web app
yeah,
that can take something like a URL or an IP, right, as an input, and then you use that to just query like what basically the service, right? And then pull down maybe the temporary IAM credential that it
yeah,
has that would get it full access, right? That's like an AWS key just fresh and ready to use so that you can
yeah,
go and do your thing.
yeah, exactly.
That's fantastic. And for as far as the access keys, I did see the president of GitLab here at RSA, and they had a they had a talk about exposed access keys and all of the exciting things that were happening this year on addressing it because I mean we have to get pretty real about the exposed access key situation, and I think that
Yeah,
we can expect some really exciting things about what new security measures are going to be put in place around this issue. But
yeah.
it's still happening, right? So what can we do about it?
Yeah, so the access keys are attackers always. The funny thing is obviously attackers need to be, let me use the term that CrowdStrike uses, the cloud conscious. So cloud conscious in the sense that they know what the cloud is, they know where keys most likely will be kept, either in environment variables or in some specific file on the file system. And so this is kind of where most developers keep keys and everybody. And because attackers know that these keys are there, and most of the time these keys are long-lived keys. So once they have access to it, they have access forever, or as long as these keys are valid. So the immediate countermeasure is number one, use for the sake of automation, use short-lived keys. So keys that don't have a long lifetime. So even if they are able to get access, maybe the key is has a validity of 1 hour. So they are bound within 1 hour within which they can use. And that leads to the next countermeasure, which is use a secret management facility or feature or product like AWS Secret Manager. And that means that the keys are not kept somewhere you need to ask for keys. And during the process of asking for keys, you might need to authenticate, and that's another safety measure. And then even if you have keys, eventually the keys are usually short-lived. So it means you are bound to use it within a specific period. So these are some of the countermeasures. And in the context of SSRF, actually, after this event happened, AWS released version 2. So all of this is happening within the context of version 1 of the IMDS. So version 2 actually remediates this vulnerability. It remediates, but not totally, because there's also possible for people to basically use not to rely on the IMDS, but to use SSM agents, which probably it's out of the scope of this discussion. But basically, if you are launching virtual machines, you can implement a measure that enforces IMDS version 2 so that they are launched with version 2 and they're not having this vulnerability embedded in them.
Okay. But for
Yeah.
those that maybe are not on version 2 quite yet, Of course, there's a lot of things that you can do to actually test an SSRF attack against your S3 bucket. And you can do that as preventative measures and see if you actually have the detection in place in order to see any kind of potential opportunity where it does become generated as an alert. So I would love to see that, how our users, our listeners can test this kind of situation. And I would also love to leave them a little bit of a leave behind of an AWS detection via our GitHub repository of how they can protect themselves against the attack as a security measure, as we were talking about.
Yeah, so what you see here is the Mitigant and cloud attack emulation. Obviously, SSR is one of the attacks. We have almost 100 other kinds of attacks. As you notice, also, we have some in the direction of Gen AI, which are targeting Amazon Bedrock. But let's just keep the focus. So if I want to launch the SSRF, if I go to the start attack button and come over here, I can actually just search for SSRF, and that's it there. And by double clicking, it's basically queued up in the center here. On the right here, we basically have a description like what we've been talking about here. It describes what this attack is all about. You can also basically write an objective. So test SSRF, right? So that's basically what you can do, because it's going to create a report that you can actually come back to later. And here are the attack steps. So it's going to launch an EC2 instance. So for the sake of emulation, we don't attack leaving like instances that are already deployed. We are basically going to spin a new one and do all the attack inside. And after the attack completion, we are basically tearing it down. So it will launch the EC2 instances. We attach an instance role for it. That role gives access to S3 and IAM. And then it will basically go through the process of getting the credential from the IMDS. And with that, it can query for the buckets, get some resources from specific S3 bucket, which it will basically exfiltrate outside of the account. So that's just for the sake of expectation management here, because this is an emulation. It's not a simulation, meaning that if you have a SOC team monitoring, or hopefully they will see some events. So let's start the attack. So you see that it has started. It basically has some preconditions over there. And then it's basically starting the EC2 instance. And that's going to take some time. It's going to spin up, I think it's called T3 micro instance. So basically a small one where all the attacks are going to occur. And that doesn't take so much time. Obviously, it needs to spin it up. It's going to basically make sure that all the information, all the resources are in the EC2 instance, all the applications or the packages that are required to perform the attack. And then it will basically do the attack. Something to mention is that everything happens over the API. So we don't usually, for the attacks, we are not installing agents. So if this was against other AWS resources like Lambda or Bedrock, it would just be executed directly over the APIs. Mm-hmm. So that takes some time. If we quickly go over to AWS, just we want to see what is happening over here. So if I go to EC2, we will see that an instance has been created. So let's see over there. Okay, that's the wrong region, but we can actually go to Frankfurt.
Which is where you are.
Which is where I am. And now we see this instance is initializing. And we can also see the instance ID, this one here. Let's copy it so we can cross-check. Refresh. So, well, I think it's still spinning it up. Let's see over here. All right, so that's the instance spin up here. So that's the same ID that I copied over there. So it has spinned up the instance at this point in time. The next thing is it's going to be conducting the attack proper. So as we saw in the flowchart before, there are a bunch of things that will occur inside of the virtual machine. It's basically going to query the metadata service. When it queries the metadata service, because this is version 1, it will basically retrieve the secret. So the secret that can be used for making API calls. Remember that we saw in the steps that this virtual machine is going to have a profile attached to it. And actually we can see that also. So over here, when it starts the virtual machine, it attaches this role. And this role has access to something. So this is typically what we do in most of the time when we are starting an EC2 instance for whatever. The instance needs to have access to do what it should do, and we will attach an instance profile, and this is done automatically. So that's the instance there. Let's see over here. So. And see what's happening here, you cannot see inside of the box, but it's basically updating here all the information it does. It queries the instance metadata service, retrieves the credentials from the metadata service, and then it basically uses it to make some queries. So it basically queries for the IAM users, then it queries for the buckets, then it basically looks at the buckets that are in S3 and retrieves some objects which it will save in this. Firstly, to save these S3 objects in the VM it spawned in the file system, and then it will take it outside of the machine. So it's like typically when attackers, actually I can make this larger. Yeah, that's the name of the bucket. It was able to access from inside of the virtual machine. And then it basically will just get some objects and save them on the file system first, and then take them out. It's a multi-step attack, which on the one hand shows what attackers will do in the real life when they are trying to either get access to things like S3 or to get access to files, objects that are S3 objects. On the other hand, as the defender, it gives you the opportunity you can imagine there are multiple detection opportunities, right? Are you able to detect when someone is, kind of making discovery calls from an S3 instance? And if that's not if that's abnormal, maybe you will detect it. And then if someone is beginning to take files from S3 into an instance like a virtual machine, if that is abnormal, maybe it's something to say, hey, why is this instance beginning to pull files from my S3 bucket? And next thing it goes out, these are all opportunities to detect malicious or suspicious activities.
I love how it shows exactly what it's doing, and you're right. It's in like completely multiple different steps of the process happening there, but also just notice how quiet this attack is. Like there was an insane like execution of malware, right? There was some privilege escalation there, which may have led to a guard duty alert, and it might have caught it, I guess, depending on the logging setups and noise
Yeah,
levels, but it could easily be super missed, right? And
yeah,
that's why the pairing of the detection matters, not just the point types of detections, right? Seeing the sequence and besides
yeah,
just each splash.
yeah, yeah,
Uh, I absolutely
yeah,
love this. I'll steal the screen back to show what kind of detections are in play here. Of course, this is our armory, our open source armory that we have, but we keep pretty active. I think these are within the last year. This one's within the last month. Kevin Lowe in our purple team contribute to a couple of different categories of data and for across different types of repositories in SQL, KQL, SPL. There's one for cloud that you can look through. We've got a pretty extensive list here, but for the IMDS in particular, what we just went through, here is the detection for that, which of course, we'll link in the show notes. But again, what we saw was a series of steps, right? Multiple steps or multi-stage attack.
yeah,
And what's important to consider is in order to mitigate, excuse the pun with mitigant, or in order to mitigate the noise, because if you just throw just one point detection everywhere, like
Yeah.
literally detect on every single time metadata is queried, it can get noisy pretty quickly because that can be a
Yes.
very legitimate use of an application. So
Yeah.
when you chain these behaviors together, right, you get that initial request, then you see if there was any escalations, any IAM users roles that were attached, and then maybe even what happens later down in that same cloud account or in that same cloud resource. That's when it gets more interesting, and that's the power of our Anvilogic threat scenarios, right? Versus just deploying these single point atomic signals, right?
Yeah.
This can happen over a period of time. And the correlation property, which is going to be the most important, which it would be interesting to test live. We didn't get to make the integration just yet, but that's the idea, and that's what we saw. So I'm really excited to see the next one because there's so many different iterations of how this could go. Uh,
Yeah.
Especially, and it's so relevant because I'm thinking about last year when we talked about maybe it was Monty's episode. Did we talk last year on our episode of this Invictus research, which these guys, I think they're over in Europe, over by you guys.
Yeah. Yeah.
Uh,
Yeah. So I think I like what you mentioned because the major problems or one of the major problem in SOC teams is alert fatigue. So everyone is
yes.
drowned with thousands of alerts. And as you saw here, if you would see the amount of logs that are being pumped into CloudTrail, just this one attack, hundreds of alerts, and people easily just kind of ignore them. So, but you can also see that what if it's a real attack, and you can clearly see the detection opportunities, which is about how you can intelligently bring this together to form a more precise detection that singles out from normal activity. And you can clearly see, well, this virtual machine shouldn't be talking to an S3 bucket and shouldn't be pulling objects back into and this is where I love it that Anvilogic already got this covered. And you mentioned about the Invictus, the release, which was very interesting because they observed that despite the fact that you have CloudTrail, you have Guard Duty, which obviously pulls from Guard Duty pulls from CloudTrail and VPC logs and other sources. They weren't able to detect certain malicious actions, which is usually, I mean, on the one hand, you have people using these services and they're super confident that, okay, everything is being seen. Unfortunately, it's kind of it's a false sense of security because it's kind of blind after all.
Yeah, and we have to get pretty real about that situation because we can't keep flying blind. You can't just turn on guard duty and think that it's there. And it
Yeah,
and even if it did generate a signal, it's generating millions of signal, probably also along with your millions of EDR signals that you're also getting. So it's how do you actually prioritize the one that matters? I guess that's the key question we all have to deal with. Still in
yeah, that's
2025, all the AI in the world is not going to help you automate your way out of an alert that's really bad in the first place. So it's so important to stage these different scenarios in a way that can filter through what is the most important, and even better if it's through the same cloud account. Oh, I got logged out here, but the different kind of chaining for entities is going
yeah,
to be key.
it's
And
key.
I want to talk about the two ones because this as you start to chain those entities, right? You can select those point detections that we talked about, but
Yeah,
you can do it across the same cloud account, the same cloud resource, or
yeah,
a correlated user. So that's
exactly,
going to be that chaining property. So
exactly.
wow, that was the SSRF leak, which of course is just one of the many ways that we can breach an S3. There's so many different ways to hack at it, and the other maybe not as advanced, as sophisticated of ways is maybe just through some abnormal IAM misuse,
Yeah,
which you can also test on Mitigant as well.
yeah. And then I will just share my screen. I hope. Yep. So we're back to the Mitigant cloud attack emulation. And as Alex mentioned, obviously the identity and access management, it's new. People say that's the new battlefield, right? That's where attackers are that's where most attacks start. And oftentimes when we are talking to people, especially because for us to do these attacks, we require some kind of access to the cloud provider service, and some of our customers are like, no, no, no. They want us to hack from outside, right? To go through the process of getting the IAM keys. And we say, we don't do that because getting the keys is not as difficult as you think, you know. And we tell them this, and because today we have like the initial access brokers, which are criminals who are in the job, or let's say their expertise is to steal keys and sell. So they don't use it themselves. They're just good at stealing keys and selling in the dark web. So
Mm.
it's really interesting. Okay. So this attack is called create login profile. So as you see, it looks super simple. A user kind of gets access to an IAM key. He
Uh-huh.
gets into the cloud account somehow, and then he optionally creates a new IAM user. So he creates another user, and then he now creates the login profile. What is the login profile? The login profile is basically a feature that allows you to use the console, like to go get into AWS using the browser. So I wouldn't say this. Sometimes I find it funny, but maybe the attackers don't want to use the CLI. They want to log in and see very clearly. Maybe that's the aim. But obviously, with this profile says, hey, this user who was created can log in to AWS using a username and password. And it's also it's a common attack that has been seen in the wild. A lot of threat actors commonly use it. And here, this is kind of the description of the attack. A new IAM user is created. He has keys, then policies attached to the user, and then this login profile is created. And of course, as you can see, there's also the chances of, this also is going to be noisy. It depends on how the settings are. But obviously, I think Anvilogic will be able to reduce the noise by chaining the different API calls. So let's say test. What is it called? Login profile. Profile. Yep. So let's hit it, and right. This is going to be way faster than the last one because it's not creating any VM. So within a few seconds, the attack is done. And over here, the description of what happened, more like the steps. So again, it created a new IAM user, and that's the name of that user. Obviously, you can easily just copy it and check in an IAM if this user was created and see when it was created, a timestamp. And then it created a key pair. So the key and the secret access key, and then it attached this policy to the user. So that's kind of the first step. In the second step, it basically created this login profile. So this user that was created in the first step, and then you basically have the login profile basically has a URL where you can sign in with a username and password. So these are the credentials, and with that, the attacker can basically just go to this URL. He has a username, he has a password. He can come in, and then he can do whatever he wants to do. And if the cloud account is not properly configured, it means that he can either create a new user, or he can just go to S3 and begin to do stuff. He can do a lot of things that he wants to do. And God forbid if it is a management account that has has child accounts at.
Yeah, the control, like access to the actual control plane itself, even.
Yeah, yeah. If it's a management account, maybe like in an organization setup where it has other AWS accounts like attached to it, like the root account, then it will be worse because the blast radius means the attacker can have access to the other child accounts to do whatever he wants, and that will be very bad.
Yeah, and I think this is also a tale as old as time because this is not another quiet one, right? Where it's not just, oops, somebody got in. It's like we're already past that point. They're building a house, right, in a cloud, and that you didn't even
Yeah,
hear them. You didn't even hear them, hammering. And so I think as well, when you think about the creating login account, this also could be a symptom of a process issue. Like why are
yeah,
who is even able to just create new users accounts like galore?
correct, correct.
I would want to be monitoring. This is a signal I would want to know every single time a new user is created, and see even
Yeah,
who have that access to make new user accounts in the first place.
yeah. Yeah, you made a very good point there because I think, this whole like this thing is about click ops, and I know some organizations they completely forbid any click ops. So
Yeah.
everything, every resource that is being created or even managed is being done by infrastructure as code, and
Mhm.
it's forbidden to log in. So if from nowhere someone is creating a login profile, meaning he wants to use the web interface, and that should be disallowed and should be triggered. The request should be denied and someone should be notified as a high profile alert. And that has to be looked at. Obviously I've seen some companies where they allow executives to log in the UI because they don't want to use CLI commands. But that's also something that a good rule can say exempt if the user is XYZ. In this case, the user created is a new user. I've also seen some correlations where they say if a user was created in less than a minute and begins to do certain things like this, the alert should be rated as a high alert so as to prioritize action against it.
Yeah, that. So so here then let's talk about the detections against it. Not only did we see the creation of the login profile, but did we go through also like assigning yourself to a particular policy?
Yes, there was something like that in the first step. So after the user was created, he basically assigned basically full access to S3. That's
Full,
that's a very
full, all of
that's a very
it.
that's a very greedy attacker. He wants everything.
A little bit of a multi-stage attack here. So what do we have in the armory that you can use today? We have the AWS create login profile, and then the attach IAM group policy detection.
Oh,
Uh,
good.
Individual, right? Individual, good at if you're deploying this detection individually, like to detect this API call individually, great. But again, if you're not chaining them, you're missing the narrative.
Yeah.
Mhm. So that was some things you can take away. We'll have our GitHub Armory, of course, in the show notes. And as far as just a couple other things as well to on the note of hygiene, because a lot of these things are issues of symptoms. We've wanted to drop a really great resource that we came across a few months ago, February. Oh my gosh, we're almost it's May 1st today.
Yeah.
It's pretty wild. Luis Machado, also another AWS community builder, published a really neat blog post on some additional, more hygienic type of strategies to keep those S3 buckets out of the headlines, starting with the least privilege principle, of course, grant only those necessary permissions for each user or service or application, right? Without these kind of broad policies, which goes back to that process issue, right? Bucket policies as well, IAM policies. If your company uses multiple accounts, establishing the SCP controls to enforce an organizational level type of restriction on authorized S3. This one, I think it was at the top of the list. Then, you talked about this one earlier, Kennedy, just blocking S3 access.
Yeah. So S3 access is, as we know, most attackers want to see what you have in S3 because S3 is cheap, everyone uses it. I think it's a good policy as part of the processes to really limit access to S3 or at least limit access to certain buckets that have sensitive information. and to just block it off and to make sure that you don't just you get notified when there are requests against such buckets.
Yeah.
And this is what, as you mentioned, you can also do it with the SCP. So you can do that at the organization level, and then you can apply it against a bunch of accounts. And I think you can also use I think you could also use things like tags. So, there's this tagging where you tag the bucket in a specific format using some specific nomenclature. And then you can say if the tag starts from XYZ, perform a certain action or deny action against the request against the bucket.
Yeah, if it doesn't require public access, like why? Like
Yeah,
why risk the accidental exposure? Server-side encryption, activate that because it ensures that even if someone does gain unauthorized access to an object, they can't read it, or they can't read it without obviously having the appropriate keys. The encryption in transit, I kind of feel silly for saying this one, but re like hard code, like hard wiring and hard requiring HTTPS connections and blocking HTTP is, I think, a pretty standard one, but it's typically not configured in all clients, applications, and services that use the AWS secure transport as an access condition.
yeah,
And lastly, the VPC endpoints. If you have it, and some folks have VPC endpoints in the organization, when using S3 within a VPC, you can create this endpoint setup so that all of the it's even kind of a fun exercise. You can define what traffic is able to go to which ones, and so that it does not traverse, right, the public internet, and it's only communicating to what it's supposed to communicate.
yeah,
Then, yeah, oh yeah, S3 object lock and versioning. Enabling object lock in compliance mode can really be super, super helpful in preventing overwritten actions, is what I've heard. And you mentioned, or like, S3 buckets can get pretty expensive, or no, are cheap. It's easy. Everyone wants to use S3 because it's very cheap to keep your
yeah,
data there. But I recently came across a Reddit article where we should be monitoring the use of our S3s, because it turned out that an empty S3 did make the AWS bucket explode. Um, which was kind of a big surprise to come back to, especially if you're not even using it for anything. So definitely.
yeah. I think it could get expensive, especially because I think when you look at it, the S3 also has, I think it's called Glacier now. So basically, some people are using S3 for things like backups for images, for databases, and stuff like that. And if you are not using it immediately, if it's already in the archive mode, you can actually push it away into another setup where the cost is much lower. So you don't have to keep it in the active, like the hot access from S3. So there are different levels of considerations, I think, and for sure it could get expensive if you don't really plan it out properly.
Yeah. But overall, though, I think it's safe to say access keys are still a big problem. There's been some steps in the right direction as it relates to helping to secure, right? What's the next evolution of uh what GitLabs is doing to keep our secrets safer. But of course, there's so much that we can do now to be more proactive about our detection measures. So,
Mm.
Kennedy, thank you so much for hacking some S3 buckets with us. That is a wrap for this episode. And I can't wait to continue collaborating on all of your AWS community content that you're launching this year. Is there anything you're working on in particular?
Yeah, we are always working on cool stuff. One of the interesting things, features we're working on in terms of attack emulation is multi-cloud attacks. So imagine that the SSRF we saw actually got keys for Azure storage. and then actually got keys for Azure account. So rather than jumping into AWS, it jumped into Azure and then began to jump around. We think it's going to be interesting because you mentioned about tying detections together. And
Yeah.
so if the detections are for different cloud service providers, there's a chance that they are seen as atomic events and they are missed. So we are really excited to do that and to see how the community will react. And I think it's another level of detection, let's say another opportunity to improve the field of detection engineering and other threat detection systems.
We've got to collab and simulate that because I'm thinking about what could be the correlating entity that spans across clouds.
Exactly.
That's gonna get complicated.
As you can imagine, yeah.
Well, until then, thank you so much for showing us how even the smallest gaps, right, a single leak key, a single missed step in this overall narrative can really flip your cloud upside down and
Yeah.
uh, and just helping us continue pushing, the community forward in the detection engineering space. So, listeners, if you like today's episode, you can drop comments, subscribe to our podcast, share it with your crew. Anyone can always use a little bit of a hygiene refresher as it relates to their AWS detection defenses. So until next time, as always, we'll catch you on our next episode.
Thank you very much. Bye.